Hello everyone, this is Ehsan. In this video we are going to shift from the world of integer numbers to something more real, because in the world of mathematics or real world we sometimes have to represent number in decimals or fractions, or what we say in mathematics real number. There are basically two ways to model real number in a computer. We are going to talk about the first one, which is a float, and it is a low precision representation of real numbers, whereas there is another version called double, which is a higher precision, at least twice as precise compared to float. So there are two standards. One is called float and the other is double. These both of them, they model real numbers, and as we understand that since the computer has a finite amount of memory, in that case they can never actually completely model a real number, but it will be somewhat of an approximation at the end nevertheless. So in order to get a value, a real number value, what we just say is we say float x is, or let's say value is equal to 1, and what we do is we always have to say this is 0.0 and then we have to change this part to f to say that we want to print a float instead of an integer. We copy paste this on the top. You don't really have to, just we're doing it for the sake of nothing. But then let's say we want to print it, and we'll see that it says it's 1.000, and we know that it's basically 1.0000000 forever. So what we could do is we could just say, if we want to see like 10 values after the decimal point, we can say 0.10, and let's run this. So it's 10 values after the decimal: 1 2 3 4 5 6 7 8 9 10. Okay, so let's say if we want to do, I don't know, 55, in that case we expect 55 zeros. Let's do this. Sorry, I made a mistake. I should say Control R. I made a mistake somewhere. I have to close all the debugger things. Let's say output, I close this, compiled output. Okay, it seems everything should be working. I go to build and run. You see it represents all of them as zeros, so it seems to be working fine. Now let's say if we want to do this, we say that say for example, let's remove all of this, and we want to say that just print a float, which is a real number modeled as a float, and we want to do this 1 divided by 10. And let's run this. Control R. I think I made a mistake. But basically what it says is this is not going to work, because we want to print a float. However, we are basically doing integer division, meaning 1 is an integer, 10 is an integer. So when we divide an integer by an integer in the computer C world, it would return an integer. So although we would expect 0.1, it will actually not give 0.1, but remove this part of the real number and just work with the integer part. So that's why it is giving us some error, and one way to fix it is basically add 0.0 at the end of both of them to say that we are trying to divide a float by a float, meaning that the result will be a float as well, and then we say Control R and it all works fine. Now here we know that if we check the result, it is 1.000, sorry, 0.10000 zeros forever. This is what we expect. So what we could do is we could do Control R. Before that we could say let's print 10 values. If we do this, we say it seems it's working fine. Well, imagine if we do actually this, Control R, and you see we expected all of them to be 0, but we have a 1 over here. Basically, what happens with the floating system is that it is not completely precise. It is trying to model a real number as accurately as possible given the constraints of the memory. So at one point, it just has to stop storing all those zero. And here in this case, it stops storing those zero at a certain point. So that's kind of an imprecision. And there is one other reason is since everything is represented by zeros and one, like meaning binary numbers in the computer, 1 by 10 doesn't have a binary representation, a completely closed binary representation. That's why it cannot be really modeled. And a similar situation is with this 1 divided by 3, which is like 0.33 forever. However, if we do this, at one point we are going to see something different. Let's see. So you see, it's supposed to be 3 all the way down to the end of the world. However, at one point it just stops storing all these things. That is because the computer cannot store infinite amount of information for a silly thing like this, because that will completely take over the whole memory and the computer will not even work when we are trying to compute something like this. So the best way is to make an approximation and stop saving values after a certain value or a certain number of decimal values. So that's why we say that we try to model real numbers in C using float and double. However, this float is a little imprecise than double. However, both of them are completely imprecise considering their real world representation. So okay, I hope you understand this.